Hello, ladies and gentlemen. It's Mr. Green again. It's time for another lesson in geometry, and we're going to be talking about quadrilaterals. Hey, wait a second. Who's this? Who are you? Wait a second. What are you trying to do to me here?
Yo, Isala, drop that beat. All right, yeah. All right, listen. It's quadrilateral time. That's why I'm busting in your classroom, spitting this rhyme. Quadrilaterals. There are plenty of types: squares, rectangles, rhombuses, kites, trapezoids, semi-isosceles. Every shape's different with its own properties. Find parallel sides. That's the way to start. You can use what you find to tell the shapes apart. Let me show you the way you can follow along. Just listen to these lyrics as I rap the song. No parallel sides, it could be a kite. Its diagonals meet at an angle that's right. If parallel sides are only one pair, then it can't be a rhombus, rectangle, or square. It's a trapezoid with legs and bases times two. If it's isosceles, we know two facts are true. Number one is the angles at the base. They got to be equal. That's a fact you can't erase. Number two, you can take it from me. Two sides are equal, that's geometry. Parallelograms, as you can see with your eyes, have two pairs of opposite parallel sides. Those sides are congruent, you can tell your mother, and their diagonals bisect each other. Take, for example, rectangle and square. The shapes are different, but properties they share. Just look, and it's easy to see. Their interior angles measure 90 degrees. Rhombus and square, they are different in name, but they both have sides that all measure the same. I hope this rap has helped you out in class, and when you take the next test, you'll be sure to pass. It's just a few simple steps to help you classify. You can take it from me, I'm the amazing math guy.
Wow, that was interesting. I don't know if I've been interrupted like that in a while. That was interesting. Okay, well, here we are. We're talking about quadrilaterals. And, what he was trying to say in that rap was, we start off looking at quadrilaterals and all the different rules that make different quadrilaterals. And I know there's a lot of them. Trust me, I've been there, done that, and I even got a T-shirt that says it. So don't even worry about it. But what we're going to look at is you have to be able to tell them apart. So like he said, where you start when you're looking at quadrilaterals, you look for parallel lines. If you don't have parallel lines, they might be one of these out here, like the kites. Pointers might help. Kites, like this out here. Or they could be trapezoids if there's only one set of parallel lines. And we'll get into trapezoids a little bit more as we go along. Parallelograms, two pairs of parallel lines. Every parallelogram could be something else, could be classified a little bit more. You've got your rectangles, your squares, and your rhombuses. These are all parallelograms. It's just they have different properties in each one of them. Rectangles has two pairs of opposite sides that are equal, but they're not all equal. Squares has all four sides equal, so a square is a rectangle. But a square is also a rhombus. Rhombus has four sides equal, but doesn't have the 90-degree corners. That's what a square has. So what you can see here with these Venn diagrams, you can see from these Venn diagrams there is some overlap in these things. So there's a lot of overlap in parallelograms. There are parallelograms that are neither rectangle, square, or rhombus, but you will be using the properties to try to determine what kind of an object you're looking at. That's what the whole thing is. Now, this is another type of a Venn diagram. What you've got is a square in the center, a rectangle, a parallelogram, and a quadrilateral. But you can also show a square is a rhombus, which is a parallelogram, and a quadrilateral. And then over here you've got a trapezoid as a quadrilateral. These are the ways that you can look at the objects, and sometimes it helps you to be able to realize that if I'm talking about a parallelogram, it is not necessarily rectangle or square. It could be a rhombus and a square, or a square, but it is still just a parallelogram. Okay? Moving forward. Here we've got an object. They're telling you it's a parallelogram. With parallelograms, we know that opposite corners are congruent. And so when they tell you that they've got an angle, DCB, which is this angle D to C to B, this angle right over here, is 121 degrees, then we know that this one up here is 121 degrees as well. When they tell you that AEB, that's this angle right here, is 113, we know that by vertical angles, that angle is equal to 113 degrees. When they tell you that AB is 15, we know that the opposite side down here is 15 because it's a parallelogram. And when they tell you that EB, that's this diagonal here, is 10, we know the diagonals are bisected, so we know that this one is 10 as well. So when they ask you in the first question here, what is the measure of DAB? DAB, well, that was this corner I said. DAB is the one that I said was equal to DCB down there. So that has a degree measurement of 121 degrees. And if they ask you what's the measure of angle DEC, well, that's the vertical angle that we were talking about earlier, and it has a 113 degree measurement. When they ask you what's the length of DC, we said, well, that was the same as AB, it'll be 15. And when they ask you ED, ED is the other side of that diagonal, and you can say, well, since one half of it's 10, this half of it's 10. That's what bisecting does for you. Okay? In a rhombus, if they tell you one side, GH, is 13, we know all the sides are 13. So we know that HJ will be 13. And if they tell you that GK, if we know that GK, which is a diagonal, or part of a diagonal there, it's the bisected portion of it, is 7, then we know that KJ will be 7 as well. If we're wanting to know HK here, we don't know anything about HK, do we? HK is the other diagonal. The diagonals in rhombuses are not congruent to each other, so we don't know anything about HK down here. Now we could use the Pythagorean theorem because we know that's a 90-degree angle in the middle, and we could take the 7 and the 13 and figure it out, but we don't know what HK is without having to do some figuring here, okay? So, in a rectangle, ABCD, well, we know it's a rectangle. That way we know the diagonals are congruent in a rectangle. And when they tell you that AM is 2x plus 7 and that MC is 4x minus 3, one of the things you can do is you can set those equal to each other and solve for x, and you get that x is equal to 5. So now that I know what x is, I can figure out what the length of each one of those bisected diagonals are. 2 times 5 is 10, plus 7 is 17. 4 times 5 is 20, minus 3 is 17. So they're both 17. So when I add those together, that diagonal AC is going to be 17 plus 17, or 34. And when I know that one of them is 34, we know the other diagonal will be 34 as well. That's what we know about a rectangle. So you can see we're using those properties to try to solve a few problems. And that's what we're talking about down here. We're looking at the properties and attributes of polygons and their component parts based upon explorations and concrete models to try and determine some things about other situations. Okay? So, hopefully you've enjoyed this video. Hopefully you'll understand the lessons. If you have problems or things you don't understand, please feel free to bring them to Class Connect or to Toga sessions and we'll talk about them. Looking forward to talking to you next time. Don't forget, if you're going to send me a K-mail, make certain you include the course number and section number so I can find you in my gradebook quickly. Talk to you later.